All right, welcome back for the second part of Unit 11 worksheet. Number 6 says to follow an acetyl-CoA through the citric acid cycle and do as you did for number 5. So I have a citric acid cycle image here from a textbook I own, and here's the acetyl-CoA. And so it enters the citric acid cycle, step 1, gets converted into citrate. And since number 5 said to indicate whether ATP or NADH is produced or consumed in each step. Well, first step, no ATP, no NADH, so nothing to do there. Moving on to step 2, we see this is just an isomerization, so nothing happens there as far as NADH or ATP. But step 3 is where we see NADH get produced. So step 3, NADH is produced, and this is for one acetyl-CoA. Remember that for glucose there are 2 acetyl-CoAs produced, but we'll just do it for 1. Moving on to step 4 down here, where alpha-ketoglutarate gets converted into succinyl-CoA. Once again, we see NADH is produced. So NAD plus is getting reduced to NADH. Alpha-ketoglutarate is getting oxidized. And then step 5, GDP is combining with an inorganic phosphate to produce GTP. And GTP is equivalent to ATP as far as energy is concerned. So we'll just say that one ATP equivalent is produced here in step 5. So we had step 4, 1 NADH produced, and step 5, 1 ATP produced. Step 6, there's an FADH2. Question 5 didn't ask to indicate whether FADH2 was involved or not, but just FYI, step 6, FADH is produced, and that's because succinate gets oxidized to fumarate, and FAD gets reduced to FADH2. Moving on to step 7, we see that nothing happens with NADH or FADH2 or ATP for that matter. Just a water comes in and is going to hydrate this alkene. For malate, step 8, final step of the citrate cycle, NAD comes in and gets reduced to NADH. So step 8, NADH is produced. And that is how you figure out the number of NADHs and ATPs produced in the citrate cycle. Okay. Alright, I'm not going to do the challenge question on the video. That's posted on the key. And it is what it is. It's a challenge question. It's not something you can expect to see on any of your assessments. Just kind of one of those fun questions if you want to challenge yourself. Okay, number 6 says what 3 metabolic processes are involved to generate ATP from fatty acids? Okay, well, if you want to get technical, the first one is the activation step. So activation, this may make 4 steps, that's okay. Activation step, that's where the coenzyme A gets placed onto the fatty acid. And then the next step is going to be beta oxidation. Remember that beta oxidation occurs and 1 NADH, 1 FADH2 is produced from each turn of the beta oxidation. But that's still not ATP. Citric acid cycle is where acetyl-CoAs are also made in beta oxidation. They enter the citric acid cycle, and those more NADH and FADH2 get made, in addition to a few GTPs one for each acetyl-CoA. So some ATP comes off in the citric acid cycle. Put in parentheses GTP. But where most of the ATP comes off, that's going to be the electron transport chain. And coupled with oxidative phosphorylation. So understanding this sequence of events that takes place for fatty acids is very important. It begins with the activation step where 2 ATPs are required to activate the fatty acid. Then beta oxidation to convert all of those fatty acids into acetyl-CoAs. Then citric acid cycle to generate the reduced coenzymes and a few ATPs. And finally the cashing in step where the NADH and FADH2 are essentially their electrons are used to convert into ATP. Okay, next question. How many beta oxidation cycles are required for a 20 carbon fatty acid? How many acetyl-CoAs can be produced by this fatty acid? Well, 20 carbon fatty acid, I'm going to divide by 2. It's going to give me 10 acetyl-CoAs because they're each 2 carbons long. And I take 10 acetyl-CoAs and subtract 1 and I get 9 beta oxidation turns. And it is that simple for answering this question. Okay. The next page. How many NADHs can be produced from a 16 carbon fatty acid? Alright. So first step, 16 carbons. I'm going to divide that by 2 to get 8 acetyl-CoAs. Which means that there will be 7 beta oxidation turns. If there's 7 beta oxidation turns, that's going to yield 7 NADHs and 7 FADH2s, along with 8 acetyl-CoAs. But here is 7 of the NADHs. Acetyl-CoA is going to enter the citric acid cycle, and 8 times 3, it will produce 24 NADHs because there are 3 NADHs produced per 8 acetyl-CoA. Since there's 8 of them, we take 8 times 3, and we get 24. So add these two together, and we end up with 31 NADHs total. Next question, how many ATPs can be produced by 12 carbon fatty acid? Okay, 12 carbon fatty acid, first thing we need to do is divide by 2. We get 6 acetyl-CoAs. Subtract 1, that's 5 beta oxidation turns. So this is going to yield 5 NADH and 5 FADH2. The 6 acetyl-CoAs is going to yield through the citric acid cycle 18, that's 6 times 3, 18 NADHs, 6 FADH2s, and 6 ATPs. I'll put in parentheses GTP. Okay, so next step is to multiply these by 2.5. Actually, I could, I'll do these separately. 2.5, this times 1.5. And when I do this, I get 9. And then when I do this, I get, let's see, 40, 45. So 45 and 9 is going to be 54. and plus 6 is going to yield 60 ATPs. Now there's kind of a shortcut. Since there's 6 acetyl-CoAs, multiply that times 10, you get 60. Because there's 10 ATPs essentially produced in each turn of the citric acid cycle. So taking 6 times 10 is the sort of the easy way out. 5 NADH times 2.5, that's going to be 12.5 ATP here. And 5 FADH2 times 1.5, that will be 7.5 ATP. Together this makes 20 additional ATP. So that's 80 ATP, but I'm not finished. I cannot forget about the activation step. So it's really 78 ATP for that 12 carbon fatty acid. Alright, I hope that video was helpful, and have a good night.